All right, you guys. So that was a little insight into life on the International Space Station, which, is a real thing. Like, they're really up there, those astronauts in space. You saw astronaut Mark first have a basketball. And when he pushed that basketball, the mass of the basketball was much smaller than his body, right? So he didn't move very much, but the basketball did. Then you saw Mark and Joe, who have similar mass, right? And Mark pushed Joe. Joe moved, and so did Mark, about the same distance from one another. Why? Because every action has an equal but opposite reaction. So Mark's action was to push Joe. The reaction was him being pushed back just as much as Joe was pushed forward. Because their masses were equal, the movement was equal. Then you had my question. What would happen if Mark was up there with an elephant, other than the elephant probably breaking a whole lot of the computer stuff? What would happen if Mark tried to push that elephant? And I know you students who are here live working on this now, you all got this right. The elephant has a much larger mass than does Mark. So if he pushed on the back of an elephant, he would move backwards, but the elephant probably wouldn't move very much. Equal but opposite force, but the movement happens, right, with the thing with the least mass. We're going to keep watching some examples of this same idea. So I have another video to show you. This video is of it's a college class. It's college physics class. So that's kind of fun. You get to see a few minutes of what a college physics class might look like. And the professor is a little wacky. So I want you to listen really well. Parts of it are going to sound exactly like what we've talked about, make total sense. Parts of it are a little more challenging. He talks about some things we haven't learned together yet. It's not a very long video, about 4 minutes. And then he does a ridiculously cool demonstration of Newton's third law with a skateboard and a fire extinguisher. Yep, just for you. All right, so we're going to go over. I'm going to screen share so you can see where to find this video. You're going to watch the video, and I don't remember if there's a question to answer. We're going to look together to see if there's a question to answer about it. Then you're going to come back to me, and we're going to do a few little experiments of our own, and then class will be done for the day. So you're almost there. All right, we're going to watch this cool, wacky professor and his experiments. Off we go. I'm holding a balloon in suspense. So, screen share. My Google Classroom. 4 of you have answered that question. Well done, everybody. Okay, so there's nothing. Newton's third law explained with a skateboard and a makeshift rocket. So you're going to watch this 4-minute video. You don't have to answer any questions on it. And then we're going to talk a little bit about it together. And then you've got one last thing to do. And that's it for class today. So here we go. Newton's third law explained with a skateboard and a makeshift rocket. Watch this and then come back for the rest of our class. Welcome back, you guys. So what did you think about that? A fire extinguisher made into a rocket. Now, probably the stuff he did in the middle with the nitrogen oxide, your teacher is stumped. The fluid nitric oxide, I think is what he was using in the middle of that video. That might have been a little confusing. Don't worry about it too much. That requires some knowledge of chemistry, which we don't have yet, and that's really okay. But what I wanted you to see was the end of that video and the middle, the part with the balloon. Remember the balloon? So here, I have a handy dandy balloon. Now, this balloon, just like his, has been filled up with air, right? Now, you all know what's going to happen. It's the same thing that's always happened when you blow up a balloon and then let it go. But were you ever able to tell your family when you did this at a party why the balloon goes flying through the air? Now you know. It's all about Newton's third law of motion. For every action, there's an equal but opposite reaction. When I let go of this balloon, the action is going to be the air moving out of the balloon through the hole. The reaction is going to be the balloon then being projected through the air, and off it will fly. For every action, there's an equal but opposite reaction. Here we go. And there it went. Action, reaction, Newton's third law. Now, if you thought that was cool, because I kind of did, I hope you did too. If you did, I've got something even better coming for you. The next video that you're going to watch shows a person, a guy, I don't know his name, using a balloon like that to create a little mini car rocket. And it's radical because you too can do this at home with just a few little things. So if you want to build a car rocket, what I've asked you to do is to watch the video and answer a question. That's all you need to do. If you have the ability to also build a balloon rocket car, you can do so for extra credit, but I do not expect you to. All I've asked you to do is watch the video and answer the question. For you students in class today, I have a special treat for you because we are going to be building balloon rocket cars. So I want you to watch the video now and answer the question, and then I'm going to walk over into your classroom with all the supplies you need, and we're going to make these balloon rocket cars, and they're going to be ridiculously cool. All right, here we go. I'm going to share my screen with you so you can see the very last bit of today's lesson, and then we'll move on. A little foreshadowing for tomorrow. Tomorrow we're going to talk together, I said again, about how Newton's 3 laws interact with the cosmos around us, why they explain why the Earth orbits around the sun and the moon orbits around the Earth. And we're going to look a little bit deeper at these 3 laws of motion, and we'll review anything you need to review to get ready for our test on Friday. So if there are things you know you haven't understood yet, go ahead and watch the videos again, or send me a little question in the comments and let me help you by answering that question for you. I am available to you whenever you need me. All right. So I'm going to screen share with you. We're going to watch that last video, and then you're done for the day. Congratulations, everyone. Way to get through your 4th day of Physics 101. All right, here's screen sharing. We're going to go down here to this demonstration of Newton's 3rd law of motion with science projects. Now, after you watch this, you're going to answer the question. This one, I'd like a few sentences to answer. The question I'm going to read to you, and then you are on your own, everybody. In this example of Newton's 3rd law in action, we see that as the air moves out of a balloon, the balloon moves forward, just like you saw in class as well. Can you come up with another real-life example of Newton's 3rd law in action? Take a moment to think about it, and then write 1 to 3 sentences explaining what that example is and how it shows that for every action, there's an equal but opposite reaction. In other words, how it shows Newton's 3rd law. That is your last assignment for today. I will see you back on Wednesday. Have a great rest of today, everybody. See you then.